Hello students, welcome to the EPG Pathshala. My name is Dr. Rajeshwari Sinha and in today's lecture we are going to learn about sampling techniques in biostatistics. This topic has been covered in 2 modules and this is the second module of the 2. In this module we will learn about various different types of sampling techniques in greater detail. We hope you have an enjoyable time listening to this lecture. In this module, we are going to look at different types of sampling techniques. Like we discussed in the last module, sampling techniques can be probability based and non-probability based. Today we are going to look at these techniques in much more detail. In the probability based sampling techniques, we have random sampling, multi-stage random sampling, stratified sampling, systematic sampling and cluster sampling. In the non-probability based sampling techniques, we will look at purposive sampling, quota sampling and sequential sampling. Let us look at each of these techniques in detail now. Random sampling. We first look at the probability based sampling technique of random sampling. It is a process of drawing a sample from a population in such a way that each member of the population has an equal chance of being selected in the sample. This is also called simple random sampling. The sample obtained by the process of random sampling is called a random sample. Random sampling may be done either by adopting a lottery method or by using a table of random numbers. Random sampling is the simplest among the various sampling techniques and it is free from personal bias. Selection of items in a random sample depends entirely on chance. When the population is homogeneous in regard to a particular characteristic being studied, random sampling is always expected to yield better results. Random sampling is used in experimental medicine or clinical trials like testing the efficacy of a particular drug. Random sampling by lottery method. Let us see how to do this. For example, suppose we want to put 20 patients on a clinical trial out of 120 patients available. To ensure randomness of selection of 20 patients, we may adopt a lottery method by numbering serially the total individual patients from 1 to 120. Then, we note down the serial number of patients on 120 slips of paper and pick one out randomly. In this way, we will pick up 20 slips of papers. The numbers contained on the slips of paper would identify the patients to be used in the sample and the 20 patients selected in this manner will form the random sample. Random sampling by table of numbers. In this process, a common method of drawing random sample is to use a table of random numbers. The table may be used as a successive single digits, as successive 2-digit numbers and as successive 3-digit numbers and so on. For example, in the table of random numbers, if we begin at row 1 and move horizontally across the page, the random order of single digits can be 3, 7, 5, 4, 2, etc. If we wish to use 2-digit numbers, the random order would be 37, 54, 20, etc. Since the digits in the table are random, they may be used vertically in both directions and horizontally in both directions. To use the table properly, it should be entered randomly. Another way would be to make slips of paper with row and column numbers and place the slips in a container, mix them up and then pick a slip of one row number and other slip having a column number. The intersection of the row and the column would be the location of the first random number. The remaining numbers would be located by moving from the first number in the direction specified prior to entering the table. Multi-stage sampling. This is also called multi-stage random sampling. In this method, the sampling procedure is carried out in several stages. The population is first divided into large groups called first stage units. These first units are then divided into smaller groups called second stage units, and second stage units are divided into third stage units and so on until we come to the ultimate units or a sample of desired size. At first, a sample of the first stage unit is chosen by any suitable methods. Then, a sample of the second stage unit is selected from each of the selected first stage units and the process is repeated from stage to stage until we reach ultimate units. A case study on multi-stage sampling. In a tuberculosis survey, Physical examination or Mantoux test may be done in all the cases of sample in the first stage. In the second stage, X-ray of the chest may be done in Mantoux positive cases, while sputum may be examined in X-ray positive cases in the third stage. The sample numbers in the second and the third stages will become successively smaller and smaller. Survey by such a procedure will be less expensive and more purposeful. Stratified sampling. This is also called stratified random sampling. It is generally used when the population is heterogeneous. The population under study is first subdivided into several homogeneous groups or classes called strata. Each stratum is called a subpopulation. Then a small sample is selected from each stratum at random in proportion to its size. All the subsamples combined together form the stratified sample. Stratified sampling is a process such as selecting sample from defined areas, social classes, ages, sexes, education levels. If proper stratification can be made so that the strata differ from each other as much as possible, but there is so much homogeneity within each stratum, then a stratified sample will give clear and better estimates of the population characteristics than a random sample of the same size. Systematic sampling. This is also called quasi-random sampling. This is a technique of forming a sample in some systematic manner, usually by taking items at regular intervals. In this method, all the units of the population are arranged in some order, either alphabetically or ascending or descending order of magnitude. If the population size is finite, all the units are first serially listed and arranged in order. Then, from the first k items, one unit is selected at random. This unit and every kth unit of the serially listed population combined together constitute a systematic sample. K refers to the sample interval, which is calculated by the formula sampling interval is equals to population size by sample size desired. An example for systematic sampling. If 20% sample is to be taken out of 1500 units of a population, then 20% of 1500 is 300. A number between 1 and 5, say 3, is selected at random with the help of a lottery method by pulling out one card after shuffling out of 5 cards serially numbered 1 to 5. Then the sample will consist of units with serial numbers 3, 3 plus 5 8, 8 plus 5 13, 13 plus 5 18 and so on till 300 units. Thus, it is essential to have a complete list of population before a systematic sample is drawn. Here, every kth element is selected from the sample after a random start. Cluster sampling. This is also known as block sampling. In this method is used units of population are natural groups or clusters such as villages, wards, blocks, slum of a town, factories, children of a school. This method is used when population is divided into groups or clusters and samples are collected in groups. The technique of cluster sampling allows small number of the target population to be sampled while the data provided is statistically valid at 95% confidence limits. From the chosen clusters, 30 in number, the entire population is surveyed. This method is easy to follow and very economical and time saving. An example on cluster sampling. Cluster sampling technique is most often used to evaluate vaccination coverage under the Universal Immunization Program, which is conducted by the World Health Organization, where only 210 children, taking 7 from each cluster in the age group below 24 months, are to be examined. That is a 30 cluster sampling. Let us see the steps involved. First is the identification of a cluster for collecting data, listing all cities, towns, villages and wards of cities within their population falling in the target area under study for evaluation, calculate cumulative population and divide the same by 30. This gives the sampling interval. Select a random number less than or equal to sampling interval having the same number of digits. The random number plus sampling interval gives the population of the second cluster. The second cluster plus sampling interval gives the population of the third cluster and so on. 30th cluster is equals to 29th cluster plus sampling interval. All houses with populations are numbered and the first house for survey in each cluster should be randomly selected with the help of the random number table. Before starting house-to-house survey, we define the age group and item which is to be studied. For example, in the evaluation of immunization, we consider the children in the age group 12 to 17 months fully immunized with 3 doses of DPT, 3 polio, 1 BCG and 1 measles vaccination. Now we start doing house-to-house survey with the selected house till we get 7 children fully immunized. Thus, 210 such children will be found in 30 clusters. Immunization coverage may also be calculated by the following formula below. The coverage is 200 divided by the eligible children in surveyed house into 100. We have now reached midway into this lecture. So far, we have looked at probability-based sampling techniques. In the next section of this lecture, we will look at non-probability based sampling techniques in detail. We will look at purposive sampling, quota sampling, sequential sampling and also understand the concept of pilot survey. Purposive sampling. This is also called judgment sampling. In this type, the individual units of a sample are chosen as according to convenience and personal choice of the investigator. The purposive selection is always subject to some kind of bias. This method is suitable for a small sample. Quota sampling. In this type of sampling, investigators are assigned definite quotas according to certain criteria. The investigators select the individuals, that is sampling units, for interviews on their personal judgments within quotas. When all or a part of the whole quota is not available or not approachable, the quota is completed by supplementing new respondents. It is very easy and time saving, but it is open to various types of errors and bias. This involves non-random selection. Sequential sampling. This method consists of a sequence of samples drawn one after another from the population depending on the results of previous samples. If the result of the first sample is not up to the mark for acceptance, the lot from which the sample was drawn is rejected and a second sample is drawn, and as before, if required, a third sample is drawn. This process will be continued till we arrive at a decision to accept the sample. This method is widely used for quality control. Pilot survey. Before conducting a large-scale statistical inquiry, it is always better to do a pilot survey, which is a small exploratory study in the field of the inquiry. Such a pilot survey will be useful in the following ways. It can reveal deficiencies in the sampling frame and sampling design. It can identify the main sources of non-response and indicate how they should be dealt with in the main survey. It will analyze the first draft of the questionnaire and reveal the defects of shortcomings, if any. It will provide insights into the problems faced by the interviewers. It can provide guidance as to the best form of administrative setup in conducting the survey. Students, we have now come to the end of this lecture. Let us summarize what we have learnt in this lecture briefly. We have learnt about the various types of sampling techniques in detail. Sampling techniques are of two types, probability based and non-probability based. Random sampling is the process of drawing a sample from a population in such a way that each member of the population has an equal chance of being selected in the sample. The sample obtained by the process of random sampling is called a random sample, and it may be by adopting lottery method or by using a table of random numbers. In a multi-stage sampling, the sampling procedure is carried out in several stages as the name suggests. Stratified sampling is used when the population is heterogeneous and population under study is further subdivided into several homogeneous groups or classes called strata. Systematic sampling is again a technique of forming a sample in some systematic manner, usually by taking items at regular intervals. Cluster sampling is used when population is divided into groups or clusters and the samples are collected in groups. In non-probability based sampling, we come across purposive sampling, where individual units of a sample are chosen as according to convenience and personal choice of the investigator. Quota sampling involves a process in which investigators are assigned definite quotas according to certain criteria. In sequential sampling, a sequence of samples drawn one after another from the population depends on the results of previous samples. Thank you for watching this lecture on sampling techniques in biostatistics.